All right, hey everybody, welcome to our first class of 2024. I hope you guys all got your course book. When you get an email from someone at Airflow now at the very bottom, you're gonna get a link to the course book so you can, oh hey Jason.
Yes, well,
Good. So you can at any time check out what's going on with our next class. There's a small chance we're gonna move next month's class because we kind of schedule a little bit of a conflict there. But so thanks for coming today. I was on vacation this past week and this woman walked up to me and asked me to take a picture of her friends. And so we got to talking. We're on the beach, lovely day. And she goes, so what are you up to next week? And I said, I'm putting on a class about duct leakage. She goes, oh my gosh, that is so hot. So in case you were wondering if this is gonna be like, you may feel like this is maybe not the sexiest content in the world, but I'll tell you, the rest of the world sees this and they're like, wow, that is super great stuff. So without any further ado, now that everybody's jacked up for this class, we're gonna get going quickly. This is like, there aren't a lot of people who teach system leakage stuff. This is an amalgamation of things. This is my investigative reporting picture from a couple of years ago. Originally it was, I had a trailer full of like duct products and Thermaduct and Koolduct and sheet metal parts. And then COVID hit right when it was done. So I took it to like 2 engineers and then I kind of moved it into this more remote format. So hopefully this is almost as good as having your hands on the stuff. All right, remote. Did I lose it? Can you just advance? Okay, and one context question. Now, one thing I've learned after doing this for 20 plus years is that nobody in the industry needs more problems. So when you're thinking about like, how do I solve a duct leakage problem? Nobody really thinks about that. Why does nobody think about it? It isn't a problem that's on anybody's radar. It's not on the engine. It's really not on the engineer's checklist to solve all the leakage problems in the system because it's, it's driven by little aspects. It's not a contractor's problem. The contractor wants to get paid, get off the job site. And whose problem does it ultimately turn out to be? It's the owner's, but the owner doesn't have like some kind of a blinking red light that says, hey, things are kind of leaky. So as we go through this, like, how do we create the context around that this might be a problem? Well, owners with big facilities, they can find it to be a problem if they dig into the weeds, right? But one thing that we generally don't know, I can ask our audience here, how much is $1 of CFM a year worth? $1? I'm sorry, the CFM. I'm sorry, that was wrong. In dollars, what is the cost of a CFM of air?
depends on the type of facility.
It always depends, but if you had one facility, could you give me the answer for how much a CFM per year costs? And usually the answer is kind of a long blank stare of like, we really don't know. I've heard as low as, like I can imagine as low as 3. Like 1 CFM of air just to move it is $1, generally $1, if it's a 24/7 facility. And a lot of our facilities are kind of running continuously, for nighttime operation anyways. So let's add filters or more filters. Let's add air conditioning, let's add heating, let's add dehumidification. What does that get up to? I've heard as high as 10, as low as 3. But if we put like $5, is that a reasonable guess for how much it costs for every CFM that we blurb out? Then you can get into the more weeds about, well, it's a plenum return system or it's still in the building envelope. Maybe that's all true. That if we have some idea of what the leakage costs us, it does drive the discussion a little bit further, is maybe we ought to pay a little bit of attention to it. So I will go back and talk about like, hey, is there a theoretical ROI on having better access doors? There could be, so we're gonna get there. Okay, so what we're gonna talk about just ductwork for a little while. And after we get through the exciting, sexy world of ductwork, we're gonna talk about the other elements in the system that leak. And finally, consideration of an execution strategy to deal with leakage. So hopefully by the end, you're gonna know like a little more about duct testing, yes. The impact of leakage, and then finally, let's tighten up those specs if you decide that this is a valuable exercise, at least for your end user. Maybe it's a conversation you have with your end user and they go, I don't care. Okay, fine. But if they do care, okay, fine. We can do it either way. Okay, so what gets tested? High pressure ductwork gets tested. Outdoor ductwork gets tested. Sometimes air handlers get tested, and everything else doesn't get tested. Any exceptions to that?
Well, I guess it's hard. I work in a lot of existing facilities. It's hard, and we make a lot of renovations. It's hard to test the ductwork per se, because I may just be modifying a section. So how do I, how does the
Yes,
contractor get in there, isolate it, test it without impacting
It is.
anything else?
almost impossible.
Exactly. So we really don't, even though the spec requires it, we can't theoretically do it, practically can't do it, I should say. So what we're validated, we have a lot of validated systems, so if we're plus or minus, if we're more than plus or minus 10,
Yep,
we get dinged, we have to go back, we have to,
sure.
but that's we're held to, plus or minus 10.
Okay. Good. Here's our code. I think we're 2013, right, everybody? Ductwork that's in, now we have no ductwork here that's tested at 3 inches. That's like class B, like medium pressure. Almost everything in Ben's, was in the sheet metal trade not too long ago. It's either high or it's low, right? So all ductwork outdoors is supposed to be tested. How much of that is tested? I've never gotten it, even with Thermaduct, I've never gotten a pressure test report, ever. Representative section, so what this is saying, if you're seeing me point, no less than 25% of the ductwork inside the building is supposed to be tested. I have a hard time imagining that actually takes place. I've heard of systems in hospitals going completely untested. Oops, the insulator already insulated it, it's too late. All sorts of stuff like that. It is supposed to be tested. Who wins in this? Anybody who gets out of this is the winner. The engineer doesn't want to follow up on it. The contractor doesn't want to do it. The insulator doesn't want to wait. It's really expensive test. I'm going to show you why. But then again, it is important. Okay. Just a reminder, air handler. Yeah. All right. High pressure ductwork here. We get to the VAV box, low pressure ductwork. That's the major designation. Pretty straightforward. I assume everybody knows that. If you're a younger engineer, that's the designation, high pressure and low pressure. What I'm going to show you shortly is how those two ducts look a little bit different. Wow, that's really small print. Hopefully you can read this. For the first time, I'm going to show you this equation, CL equals F over P to the 0.65 power. If you guys remember old high school math, you need to turn your iPhone calculator sideways to do this calculation. Well, what's F? F is the measured leakage per 100 square feet of duct. P is our pressure, and CL is the class. We're going to dig into this too. I've been doing HVAC stuff for 28 years now. I never knew any of this stuff. It wasn't like it was first and foremost. So if it's new for you, don't feel bad. I did it for 25 years before I had any idea about duct leakage at all. Let's keep going. Different stuff in California. California requires everything to be seal class A. I'm going to tell you a little bit of, well, I'm going to tell you a lot of it about what seal class is. It means basically everything in California is made like it's high pressure ductwork, or it's sealed like it's high pressure ductwork. Why? Because California is way more stringent about energy codes than anywhere else. And as we're starting to see with electrification, those things tend to move from the coasts inward. So maybe this is on a radar. And I would say this is actually really good legislation. Duct leakage, we'll get to the end, but it can be a big deal. Okay. How do we do it? Now, I've never been in the field to witness a duct pressure test, but I'm going to show you a video because if you haven't been in the field to do it, great. Can you help me with this, Sienna? Oh, geez. Just pause for 1 sec. Hey, in the audience, If someone can raise their hand just to make sure we're sharing the video properly. We're good. Okay, great. Thank you. Great name.
There he is.
Q&A says. There's a Q&A says. What's on the video? Just pause it. Sounds like we're not getting remote audio here. Let's just stop and I think you just need to share computer sound. More. Share sound. There we go.
Oh, sorry. Start that real quick.
Yeah, we're just gonna.
I don't know that you gotta go to the beginning. We don't need to see him set it up.
I
I think everybody gets the idea.
I was concerned with his duct tape not being sufficiently.
No.
Sealed.
First of all,
Not being sealed.
if you're still hearing me out there, number one, it's called the DOLT system, which is the worst name ever for a testing product. And all he's saying is he has got a tester and he is gonna measure the amount, he's gonna measure the amount of ductwork. It's just, you know, how many square feet of ductwork do we have? He puts in the pressure class and then he runs this test and he's blowing up the duct. And what that system does is measures how much extra CFM goes through to maintain whatever static pressure it is. So he blows it up to 6 inches. Once he hits 6 inches, how many CFM are required to maintain 6 inches of pressure? And that's the leakage. So we can kind of keep playing here, but that's basically the gist of it.
6.1 inches in the duct right now. So now we're going to hit next. And now we basically are going to begin the test. The test that we're allowed to leak, because our limit is 6.588. We're leaking on this duct at 3.172. This gives us a pass thing. So what we're going to do is we're going to, and we'll show the data.
All right, that's all the video we need to see. Go back to the presentation. Great. So that's what it looks like. It's just a high pressure blower to blow that ductwork up like a balloon. Okay. And I still have control. Okay. Yep. All right, so this chart is a chart I made once upon a time to help me try to figure out like how much leakage was okay. That formula up at the top, the class, the leakage, 100 square feet, and the pressure. Now notice the pressure is at a exponential that's less than 1. So what it tells us is, yes, pressure is important, but what's really important is how many holes are there in the duct. So we're derating the pressure to a certain extent. So most of our systems are tested at 4 inches for high pressure. And there are some at 6 and some at 8, and almost none at 3. And then everything that's low pressure is 2. Now notice, everything that's high pressure is called seal class A. And we're going to talk about what that means. And then as the pressure gets lower, we change the seal class. But as at 4 inches of pressure, we are allowed to leak 9.1 CFM per 100 square feet, which doesn't sound like a lot. But your system may have more than 100 square feet of duct. This is not linear feet of duct, this is the square footage of the perimeter of the duct. Now notice, when we get in the low pressure duct, it kind of is like you can leak all you want. We can leak three or 2.5 times as much. I'm gonna show you guys what Koolduct is. No matter how you build Koolduct, it's leakage class 3. That means the leakage drops, so it's about 1/5 of what low pressure ductwork is. If you go to Thermaduct, which we'll talk about later, that's outdoor ducting, it barely leaks at all. But again, we're on the inside of the building right now. Quick math, 100 square feet of 4x2 ductwork, like a very common, I don't know, not 10,000, but less than that, CFM air handler, you're allowed to leak in that much ductwork, 109.2. Ironically, in the same square footage of class C ductwork, you're allowed to leak 3 times as much. Now, quick question, which, does it cost less on the low pressure side to leak more? Like, is losing a CFM on the low pressure side less valuable than losing a CFM on the high pressure side? It's all the same, right? So I don't get why this is SMACNA. It says like on the class intro, SMACNA is sort of teaching this. They're not teaching the class, but it's SMACNA's data. Well, we allow the low pressure side to leak a lot more, which to me, it would be way easier to seal up the low pressure side. But this is how it works. So if you build ductwork that leaks 300 CFM per 100, 1,200 square feet, it leaks 300 CFM at 5 or 10 or $3. That's good. Contractor did a great job. And if it leaks less on the high pressure, contractor did good. Also check the box. So this is what, when we write in accordance with SMACNA, this is what we're getting.
Is this where the plus or minus 10% comes from?
There's no plus or minus 10% SMACNA.
So I guess that came from somewhere, right?
We're gonna
Actually,
get there.
okay.
We're gonna get there. Okay. When a contractor builds ductwork, they use a Pittsburgh. Now, this is not a full Pittsburgh, but this is basically what a Pittsburgh seam starts off with. Take a break, they fold one side all the way over, and they take the other side, and they make a 90. That is a Pittsburgh seam. Does it look airtight to you? Do you want to have it hold a bucket of water for you? Water being a fluid. Now, it does get bent over again. And they do put sealer in it, so it's not like, oh my God, this is like everything leaks like a sieve. But that's what, when a contractor says that's what a Pittsburgh, that's what the start of a Pittsburgh seam is. I'll show you another picture here in a minute. Okay, so we're going to show you a little picture of after the duct square is built. Sienna's going to kind of walk us through this video. There is no sound, so out there in our audience remotely, we want to go back a little bit further to the beginning. Sorry. When they're putting the 4 bolts together, just before this. We can zip through it quick. Okay, right there is good. So this is just a 4-bolt flange, so it could be Ward or TDC or TDF. And it's not a lot of rocket science. You have pieces that just get popped together, and you're building a picture frame, right? So pretty straightforward. That's when the contractor says, we got to put the corners on. Those are the corners, right? You can go a little bit quicker now, Sienna. And that highly scientific, no, just with your, yeah. So just tapping it together. So there's no sealer yet. Right, so there's our frame. Now we're gonna put it on the top of the duct. And it should be kind of a snug fit, but you notice like still, even though we're, banging this thing together, it still isn't like a sealed up kind of a system.
There's caulk on the inside of those.
There is caulk inside those, okay, and there should be, right? Right, so this is just screwing, Sienna, we can go a little bit quicker now. And then we're gonna put some butyl tape on, and then we're gonna bring over our second section. And this is how it goes together in the, and this is, all high pressure ductwork is built this way. And then, yeah, we're just bolting it together, and then we have this tool that bends that, I don't know what you call it, that C-clamp over. Cleat. And that's it. So there's your straight, I'm glad you're here, Ben.
So.
No, I'm not a sheet metal contractor, right? But. Alright, so back to that. Alright, now I'm gonna show you our phenolic duct product. Just so not that it's like, it's just a little bit different. So we're gonna play this video next. So this is, instead of being a sheet metal product, it's still a yellow label product. What are we doing?
I was gonna add, Tom, I had one project where I had to point out that they had not installed the cleats.
Oh,
in
yeah.
all the joints.
Oh, that's fun. So this is how Kingspan Koolduct gets manufactured for the high pressure side. So notice it's not a flat sheet. They're machining out 45s and making the ends smooth. They just bend this up, and now it is an insulated duct. Those are just tiger clips. Close them up. And a UL tape and a squeegee. You gotta tape all the open sides because you don't want the phenolic exposed to the duct. I don't think there's anything wrong with phenolic, but you just don't want it in there. A little squeegee goes all the way around. And then this frame, notice that the frame is built so it sits on both sides of that insulated panel. But when it gets to the field, it looks exactly the same as what the contractor is already familiar with. It's the same 4-bolt flange that they're comfortable with. Even though we've got all this material, we still seal the joints.
How long are sections typically?
Usually either 4 foot or 13. Sometimes you make it as a C and sometimes you make it as an L. You can, yeah, even the little corners you gotta get. This is all in the installation manual. And that's it. So almost exactly the same as duct, other than the fact that the insulation and the duct are the same piece. There's no other duct that needs to come together with this. But we're gonna talk about that in a minute. So that high pressure seal class 8 duct is leakage class 4. This is leakage class 3. So it's as good as, it's a little bit better. All right, now that's high pressure side. Everything looks the same. Here's the low pressure side. We're gonna play that lower left Ductmate Industries video. Play the whole thing.
Here at Ductmate Industries, we manufacture standing S and hem slip drive, which is used for residential or light commercial duct, depending on the duct size. The standing S is cut 1/2 inch shorter than the duct size and installed on the raw edge of top and bottom of the duct. Bring the duct together on one side and drive the drive cleat on and hammer the tab over on each end of the drive. Repeat process on opposite side. The hemmed S slip is also cut 1/2 inch shorter than the duct size and is installed on the raw edge of the top and bottom of the duct. Review product spec sheet for available alloys, gauges, and cut the length of slips and drives. Thank you for watching this video from Ductmate Industries.
Now, what didn't you see in the SM drive yet? No call. Okay. And if you play the, yeah, thank you. You're right on this. I don't even want to keep talking. This is my business partner, Adam, putting together just a low pressure section of duct, 2 pieces together.
Is that like fiber ducts?
No, it's in the realm of the weight of fiber duct. It's a good tire clip picture. going, Jason. Checking up on our work, I like that, I like that. All right, that's good. You guys get the gist of it, right? So that's low pressure duct. On the left, what he's building right now without any sealer is leakage class 48. What Adam's building on the right is leakage class 3, so 116. Now, we're not gonna let leakage class 48 ductwork get installed on our jobs according to code, so I'm gonna show you guys how we get from 48 to another number. I can go ahead and go back to the presentation. Okay, incidentally, this Koolduct product won an innovation award a few years ago. And something else that's come up, when you use Koolduct instead of galvanized, the, what is this? This is the carbon footprint, the impregnated carbon of the product with galvanized uses a lot of fossil fuels. And so this is just comparison of like about 1/3 the, basically carbon footprint using Koolduct versus metal. And I'm sure there's lots of variations on this. This is a low pressure ductwork comparison, but someday we're gonna probably get to the point where we're measuring all the stuff that goes into the building and taking it instead of just what we're burning in while we have the building. So we may see more phenolic ductwork coming up in the future. All right, leakage classes. We're gonna seal this ductwork up. Anything high pressure before the VAV box is called seal class A, which when I read this, I'm like, I don't know what any of these things are. Joints, seams, and wall penetrations. We're not gonna worry about B. Seal, or seal class C is transverse joints. Okay, what are those things? If I'm gonna build, oh, let me go back. This is just, these things are just buckets of hard cast and caulk. So whether or not they're using kind of a brush or whether they're using a caulk gun, you can seal however you want to seal, it's got to get sealed. I'm sure every contractor has some sealer guy selling whatever stuff, this is the better sealer, that's a better sealer, whatever. Okay, so in this first top picture, the longitudinal seam, so when we make that Pittsburgh and we bend it all the way around, the fourth side, we got to fold it up. And that seam, the longitudinal seam, that's one thing. The transverse joint is another, and then when we put a hole in the scod, please don't do this, but that's what the wall penetration is. So when we do seal class C, so everything on the low pressure side, the only thing that we need to do is this transverse joint. So when we put those two pieces together, that Pittsburgh seam, like I showed you before, there's a full-on Pittsburgh seam. This doesn't need to get sealed for low pressure ductwork. Some contractors actually do seal it, some don't. There's no inspection process for this. Maybe if an owner and a contractor have a good relationship, they say, hey, I want all my low pressure ductwork sealed, maybe they don't. But even this one, again, this is a bad one, it's just for example, but this doesn't need to be sealed. So you cut a hole in the side of the ductwork, you put a tap on it. Theoretically, you think that that's gonna leak, but it doesn't need to be sealed once it's low pressure ductwork, where all your little takeoffs and fittings and all that stuff is. So again, SMACNA says this is cool, that's what you get. All right, so seal class A, that longitudinal seam where we fold up our duct, there could be two seams, there could be one seam, there could be more if it's really big, and then transverse joint and then the walls. Okay, moving on. Just checking my time here, all right. Notice, so some of the duct machines, I don't know if you can see this, there's a little blue thing here. They'll put a little bit of sealer in the machine right when they fold it up. So imagine a contractor that's got a coil line with a sealer built into it, probably always seals up that joint, which is good. But notice, you got a very little bit of sealer and a knife edge going into it. This is what Koolduct looks like. And then we seal the corner. So you can imagine why it's leakage class 3 all the time. Okay, so here we are in the field. Again, that terrible wall penetration. Contractor, maybe this is return ductwork. Contractor did a great job sealing up that joint, right? That's top notch. I wonder what he did up here.
Hopefully you reached over the top.
Maybe they did, maybe they didn't. One cool thing about Koolduct is when you're out in the field, there's no insulation to go over the top. So you can see how everything's sealed up or not, and it should be sealed up, right? So we'll keep talking about Koolduct in a little bit. I think this is from your job.
Oh,
Yeah, so here's looks like a field, good news, bad news. The good news is the contractor did a field pressure test. The bad news, he probably should have done it before the duct was insulated. So he's got peel and seal, and then he had to punch a hole in it to do the pressure tests. Get that pressure test done before there's upside and downside to that too. We'll talk about that the next hour when we're talking about more outdoor duct. This is just a quick picture of VentureClad. You can see that the ductwork is leaking because it's billowing out. So we're pushing the insulation away from the duct.
terrible
Just-
product.
Yeah, well, it's a product that everybody uses. More
Doesn't make it right
pictures.
though. I mean, look at it. I mean, that was just, it was just
It's puffy.
Yeah, it's
clearly
I don't
not
wanna be a
sealed.
pirate.
I mean, it just, how long is that gonna
I don't
last?
want to be a pirate.
You know what I'm saying? Like, how long is that? That was day one,
Who goes out and looks at this?
the owner, and then they come back,
Never does.
well, they should.
All right, this is what it could look like.
That's what I wanted it to look like.
That's what it could look like. Nobody's paying Jason for all this commentary and stuff. All right, so that's ductwork. We covered ductwork. We did pretty quick in about 30 minutes. All right, now we're gonna talk about everything else that leaks, which there's a lot of stuff, and it probably leaks worse, if you can believe it, worse than the ductwork. So who knows what this is? Fire smoke damper, terminal box, access door. We talked about the low pressure ductwork, right? What leaks, what doesn't? All right. We talked about this. Now, again, how do we test low pressure ductwork?
Don't.
What?
We don't?
We don't. We don't. So how do we actually know if the low pressure ductwork leaks?
Well, if you know what's going through your terminal device, you,
Right.
and then after you do the
Yes.
tab, you know what's coming out all your outlets.
Yeah.
Your-
And then if the balancer can somehow get that number within 10%, we're good. Is 10%, that's just downstream of the VAV box. Is 10% of your system leakage good? It's not that good. Really not that good. I mean, think about just the fan law. 0.9 cubed is the horsepower penalty. That's not good. And then all the air conditioning, filtering, heating, dehumidification that you accomplished, you just threw it into the plenum. Okay, well, we've covered this. So if we get to this 25.1 number, bingo, yes.
Question in the chat from Fred Betts says, what mechanism do code officials have to enforce the leakage test?
What mechanism do code officials have? I'm gonna answer the question with a question. I've never heard of it being done. I believe it's really on the engineer to hold the contractor accountable, and that's a difficult battle. I don't hear a lot about, oh, we got bounced on leakage.
But the same thing as, the same question could be asked about just building envelope leakage.
Absolutely.
It's-
Absolutely.
Nobody's, like, how do they?
Do code officials actually know about this?
California maybe.
California, they do. Here, no. I mean, I've never heard of it. Never heard of it. If it was enforced, well, let me turn that around. DFD, state-run projects, there is a guy who is in charge of all the duct testing for all of the state of Wisconsin, and he runs a tight ship. And if you don't pass, you don't pass. You're going back there and you're fixing it. But he's dedicated to it. And there's enough buildings to probably make it worthwhile. Code officials, I don't know how they're keeping track of all the stuff they're supposed to be code officialing, but it's a lot. Okay, so we talked about low pressure ductwork to some extent. If your spec says 5, okay, you could probably enforce 5. We hear enough of stuff about balancers as it is. Okay, now this is kind of a fun fact. In the field, you have to cap off. So we saw that Dolt system on pressure testing the ductwork. In the field, someone would have to come in front of this fire smoke damper and blank it off and test in the mechanical room, between the air handler and the fire smoke damper. Why would that be? Because the fire smoke damper leaks a lot, not through everybody thinks about fire smoke dampers and leakage through the damper, but the issue is the leakage through the casing. So through the casing, well, oops, sorry, we've got electronic fuse switch here, we've got the actuator penetration, the jack shaft, and we've got all these little bolts, right, in this frame that attaches to the sleeve. Well, it leaks through the sleeve. So the contractor's got to build a wall in front of this thing and build a wall behind this thing in order to get his ductwork tested. Why? Because the damper leaks too, he would fail the test. Okay. Oops, sorry. Wow, really far. Okay, terminal boxes. Do terminal box casings leak? What agency does the testing for terminal box casing leakage?
Manufacturer?
None, there is none. There is no test for casing leakage. Some manufacturers have a certified low leakage casing box, or you get what you get. Can you use the damper for a pressure test? You cannot, the damper leaks too much, so you have to stop your test in front of the box, which makes sense because you're switching from high pressure to low pressure, but that box leaks some. We're gonna talk a little bit about that. And then our guest speaker, Mark Mann, is gonna talk about that more in depth if I get moving here. Okay. And I'm not gonna talk about BEVs more because Mark's gonna take over. This is just a little thing. Here's SMACNA rated Ruskin, that's a good brand, it's SMACNA rated. It's a 2x2 access door. How much does the hinge door, how much does it leak? Well, we talked about maybe $5 a CFM, right? On the low end. So two inch pressure, 2x2 door. So where's our pressure? Our pressure is here, 2 inches. We go across this double skin hinged access door. This is for a 12x12, it leaks like 8 CFM, 7 CFM, so times 4. So 24 CFM times $5. It's $100 a year just out of that access door. The access door doesn't cost $100, but it leaks $100 worth at least every year. Okay. Looking at the system, we know that the air handler leaks. If it's a custom air handler, it might be 0.5%. If it's a modular air handler, it might be 1%. Air handlers have their own leakage tests. We're not covering it here. They should have pressure, they should have, all air handlers do have a pressure class that they meet, and it's usually in their specification. It still needs to be tested, right? And we talked about ductwork, roughly 1%. Again, we're following that pressure test. Our VAV box, 2 to 3%. Again, Mark's gonna talk about that. Finally, no test on the low pressure ductwork unless you miss on the balance report. And if it gets caught. If it gets caught. So we're doing a lot of work up here, and then we're blurping it all out at the end, which kind of sucks. Okay. This is like, okay, so where are we gonna put our caps to do pressure testing? Remember, the code says what percentage of ductwork on the inside of the building? 25%. So I've got an air handler, I'm gonna put a cap here so I can test the air handler. And I'm gonna run this test right here and I gotta stop. Why do I have to stop? Because there's a fire smoke damper at the wall penetration where the shaft is. And I can only test this much ductwork. If that's an 8-story shaft, I gotta do another test. On the return side, to get to 25%, I've got this little bit. So it is an epic pain in the butt. Figure out where you're gonna test if the fire smoke dampers leak. Look at that. And there's a lot of caps to get to 25%. Lot. Okay, so one at a time, we're gonna tackle this and I'm gonna turn it over to Mark. Okay. Damper leakage to atmosphere. So Ruskin came out with this. Again, nobody's really talking a lot about duct leakage. However, if you want to get smart, you notice that here's a smoke damper sleeve. And we talked about high pressure ductwork, we need to be leakage class 4. So they've got a chart for leakage, not through the damper, but leakage through the side of the damper, through the sleeve. Here's leakage class 3, here's leakage class 2, and this damper doesn't leak through the sleeve. So Ruskin has this now. So what does that mean? If you're doing field testing, you can test way more duct and go right through the damper. So that's a huge benefit to the contractor. Do contractors know this and say, ooh, I want to get Ruskin life safety dampers because the sleeves don't leak? No, they don't. Probably because they're probably not testing that much, but the problem is solved. Okay, so this is fire smoke damper leakage. Here's the damper, here's class 2, here's class 3, here's a fire damper, here's class 2. So you can get over the life safety thing if you use Ruskin. I don't know if other guys have tight sleeves, but you can solve a lot of testing issues with just this little bit and a little bit of information. Okay. Standard VAV box construction, 2 to 3%. Mark's gonna cover this in a couple of minutes. Here's just your side tap, right? Off the main, we're gonna run around out to a diffuser. Look, this little guy's got a grommet on it. And this one has a hole. Which ones did the contractor buy? I don't know. You guys review this in shop drawing group? I have no idea. Maybe you do, maybe you don't. This is an access door, a round one. Oh, wait, wow, that's crazy. At 4 inches, it leaks not one CFM per square, one CFM. Is this access door $100 more than, who cares? Like, specify access doors that don't leak. Do you need access doors in every job? Pretty much. Okay. Can you make it work? I'm sure the contractor is fully capable of cutting a round hole instead of a square one. Low pressure ductwork. Yeah, you can test more stringently. Other options, as an engineer, you could say, I want all high pressure ductwork everywhere. I want all seal class A. Now, what do you have to do if you're going to specify all seal class A for a contractor? You're going to need to go out and inspect it and make sure, because that may be great. The estimator may estimate all seal class A ductwork, but then the guy in the field gets there and he goes, wait, this is low pressure. I don't have to seal this stuff up. So the communication between the office and the field may not be perfect. So it's going to require engineer's intervention. Option 2, round, is leakage class 2. Like good spiral ductwork is only leakage class 2. Finally, you can use Koolduct on the low, like do whatever you want on the high pressure side. On the low pressure side, you can use Koolduct because it's always leakage class 3. Just a fun fact, when you build Koolduct, because it's duct and insulation, you can run it all the way up to the deck. Whereas if you have, low pressure duct, any duct work, you have to leave 6 to 8 inches above it so you can get 2 layers of insulation over the top. So if you've got a tight ceiling space, and all the architects want their ceilings as high as they can, this is a way to give them something that they want. I just did a ballpark estimate a couple of years ago. If it was $3 a CFM, which is really low, and if your system cost was $25, which is probably too cheap, if you paid a premium for that system to make it low leak, and you paid $1, so we went from 25 bucks to 26 bucks. What would the payback be? And looking at basically a teeny little, not a teeny, but a medium-sized office building, like our office could be something like this. So, it's gonna take more engineering time, so when you turn in your fee, make sure you've got some extra time there to make sure that the contractor does, and that the balancer does, all those things, right? There's no payback for the owner yet. Add 3 more pressure tests. Pressure test is about 750 bucks worth of horsing around. If you use life safety dampers that don't leak through the sleeve, you're gonna get these tests back anyways. This is can be a free thing. Just test more ductwork. Don't test 0. And maybe instead of testing 25%, you do 25% high and 25% low. See what you get. And if they fail, hey, write that in your spec. If you fail, you gotta test more. Okay, and then you can, again, we're gonna talk about boxes in a second, use ultra low leak access doors. This is a diffuser with a raised collar. And normally that diffuser has just a 1/2 inch lip on it. You can get a raised beaded neck, it's 2.5 inches. Contractors don't love this because it's kind of hard to get the flex over the bead. Ben's shaking his head positively. It is hard. It's hard
It's easier with the beaded neck to get like the.
to get it sealed.
To get the pandoid on.
Yeah, well, because you're going from a 1/2 inch to 2.5 inches. So there's a trade-off there. Otherwise, you're supposed to, you're supposed to put the flex on, and you're supposed to panduit strap it, then you're supposed to tape it. And then then you put the insulation on, and then you panduit and tape it again. Well, with a 1/2 inch, there's not a lot of room there to really be monkeying around. So if you go out in the field and you're losing a lot of air, odds are the flex just slipped off the diffuser, and that's a really easy fix. It costs $5 a diffuser. Ooh, oh my gosh, like we're gonna break the budget, right? Not that big of a deal, but if a contractor's buying diffusers and your diffuser costs $5 more, you're losing that job. It's not happening. Life safety damper, low leak sleeve, no cost. No cost. And then if you buy this higher end ductwork, it's gonna cost, but it'll have a payback. Now, who measures this? Nobody. So again, all the way back to the beginning of what problem are we trying to solve? An invisible one. So it's up to the engineer in the first place, or the design build contractor, same matter, to say, this is important. For the end user, yeah, they don't know about it. It's kind of like eating your vegetables. I don't know if I eat my vegetables every day, if I'm gonna prevent cancer, but I know that if over time, I do the right thing over time, I'm gonna have better results. So eat your vegetables. All right, and this is just a recap on all that stuff. And we're at 10:47. So Mark, can we get our other host on?
I'm here. I'm gonna
All
hop
right,
on.
awesome. Yeah. All right, so you're on. So ladies and gentlemen, Mark Mann is a business development product manager, specialty guy from Price Industries. He's going to be talking about some new things and old things about terminal boxes. And he's going to go for about 25 minutes, and then we're going to take a break, and then we'll wrap up the second half with outdoor ductwork. Hey, Mark, thanks for, I shouldn't even look at this. Hey, Mark, thanks for hopping in, and I'll let you take over from that for now.
Beautiful. Thank you, Tom. And sorry to everyone for my blurred background. I'm on the road this week, but really wanted to hop in to kind of share some thoughts and commentary on leakage, because it's something similarly to Tom I care about, and I actually see it mostly because of the variety of markets that I'm kind of in on a regular basis. Want to speak to my background really quickly, a couple comments on some of Tom's material that I think, I can kind of maybe add a note from another perspective on, and then I'll dive into my material. But kicking it off with my background, so I've been with Price for 9 years, and I started at Price Industries in our research and development lab. And in the lab, product testing was primarily what I was working on and doing. And a couple things I wanted to note that I thought were maybe applicable. One, which is interesting, the Winnipeg lab, I'm now located in the United States, but Price's main lab is in Winnipeg. That's where I started my career. The Winnipeg lab uses phenolic duct for all of our kind of made to measure ductwork for custom product testing. And the main reason why we do that is it's way easier to work with. It is way lower leakage, so we don't have to verify and test ductwork that we're creating for leakage to the same extent we would need to if it was just galvanized. And the ease of use on it is incredible. So I'm not here to help pitch the rest of Tom's line card and phenolic duct, but I will say we used it all the time in the lab in Winnipeg for those same benefits. Another thing I wanted to note, which was a short kind of slide, but it was one that's interesting. The embodied carbon comparison between phenolic duct and galv. My only comment to that is at price, we're starting to look into embodied carbon reporting for our products. It's something that's coming up now on the West Coast as an actual requirement on projects, especially when we look to, the larger firms that are creating a ton of square footage and are very considerate about their carbon emissions, about, LEED certifications. So that is a trend that I think will grow and continue. And knowing that you're using low embodied carbon product could be a benefit downstream. And then the last thing I wanted to comment on, or actually two quick things. Seal Class A in California. I have a contact in California from a large engineering firm, the owner of a large engineering firm in LA, who estimates for them comfort cooling, 1 CFM is worth $12 to $16. That's for specifically comfort cooling applications. Now, market to market, the cost of energy is a huge component that is going to cause that to vary. But anecdotally, I think why California's Title 24 energy code has gone that direction is because it's more affordable in the long run to pay for sealing and good quality ductwork than it is to pay for additional testing and rework. So that's a consideration there. My last comment, and I think it's an important one, Tom kind of referred to who holds who accountable in the leakage discussion. Generally, I agree. It's not code officials because they can't easily test and understand leakage. I think really it's the owner. And there are examples of this even in markets where leakage isn't as, we'll say, mandated by local building codes. But a good example is Texas. The University of Texas institutional system, hospital system is the example of an owner that cares about leakage more than anyone else, in my experience in the United States. And originally it was a testing and balancing company and an engineer who partnered together and kind of pitched the University of Texas on leakage and the cost of leakage and the impacts of leakage to energy efficiency, comfort, all of these things. And then from an ownership level, they have picked specific engineers that they will work with who will really meet their requirements. So I think maybe if you're looking at this as a value add, or how can you kind of drive more business to your firms, talk to owners about it. And I think owners, if they hear the right story, they'll care because it is impactful. But generally, my view is the owner is the one who kind of holds things accountable. So to kick things off, I was talking to Tom this morning, and I actually threw this slide together last minute, but I wanted to start with a story about leakage because it's topical for me right now. When thinking about why should we care about leakage, well, I care about it because I have a presentation for you guys on it today. And then in about an hour, I'm meeting with an owner's rep for a very large building in the Northeast, the principal of a very large engineering firm in the Northeast, and a number of manufacturers, because there's a project that is having massive leakage issues right now. And when we think about why should we care, it's maybe even just avoiding scenarios like this. So this is an office project, and it's a chilled beam project. So for anyone who's not familiar with chilled beams, the short pitch on it is it's a sensible only cooling solution that shoots high velocity air, creates a low pressure kind of environment internal to this chilled beam that entrains and draws room air back up through a cooling coil that sensibly cools that air down and then kind of shoots it to the space through nozzles. So this is a very energy efficient solution. It works great, but interestingly, it needs a lot of pressure at the actual chilled beam terminal to operate correctly. It needs 0.6 to 0.8 inches of pressure at the inlet. So when we look at the schematic on the left, we have 4 chilled beams. It's being served by 1 fan powered box. And that means that pressure, the pressure of that ductwork is realistically over an inch. So a lot higher than the 1/4 inch we'd maybe normally see in low pressure ductwork. Another factor here is the fan powered box that they chose. So I would argue a misapplication or not the right product to use here. They're using a fan powered box, a parallel orientation, which we can see is yellow in the bottom left, and then we can see a render of it on the screen. And this product has a huge hole in the side and is generally used in low pressure applications. But in this case, we're seeing about 1.2 inches of downstream static pressure for the terminal. And a big hole in the side means leakage out the side of the product. When we look at the spec, which is in the top right for this product, there's no casing leakage specified whatsoever. There's damper leakage, but no casing leakage. And so we have a number of factors here: a higher pressure system, a low pressure duct specification, which is insufficient, seal class C only, a very low leakage class for the ductwork as well. We have a parallel box with a hole in the side. Traditionally, parallel boxes have higher casing pressure. We're now in a scenario where this project has been built and is going through commissioning. We don't have the plus or minus 10% airflow we need, and Price as a manufacturer fully complies with the spec and never even really interfaced with the project until it was built. So hopefully I'll give some understanding of how we can manage this upstream and avoid projects like this in your market. And there's things to avoid even if you're not using chilled beams in series with parallel fan powered boxes. So another note for anybody who's in the room at Airflow with Tom and team, feel free to just, shout out questions in the same way you were with him. I can hear you. I'm happy to address questions on the fly. But I'll dive in now with talking about the leakage food chain a little bit because I think it gives some good context to the terminal. So looking at the leakage food chain, the actual leakage we care about is system leakage. How much air is leaking out of the entire HVAC system? What air is being conditioned and not delivered in a useful manner to the occupant? Tom talked a lot about duct leakage. So the leakage of air from ductwork. The important thing I want to note is system leakage includes all of the leakages below. Duct leakage is just duct leakage. It doesn't include equipment or accessory leakage. It does include those transverse joints or wall penetrations, so potentially ductwork mating up to equipment, but it does not include equipment whatsoever. Equipment leakage, therefore, is not tested, not managed at all by kind of standard leakage language from SMACNA or ASHRAE, and that's the leakage specifically from HVAC equipment. In my case and in my scope, we'll look at terminals here. And interestingly, it actually doesn't include necessarily equipment accessories at all. So the last leakage here, which we'll also talk about, is accessory leakage. And that's the leakage from a specific accessory or appurtenance. So is it an electric heater? Is it an access door? Are we looking at water coils and the slip and drive seams on water coils, or potentially an integral attenuator or silencer, or a duct mounted attenuator or silencer? That's accessory leakage, and that, once again, is separate and managed separately. So why should we actually care about leakage? I think that's an important component to the discussion as well. Leakage can obviously indicate wasted energy, but that's not necessarily always true. Supply leakage into an unconditioned space would be wasted energy that isn't achieving comfort or isn't achieving ventilation. It's a problem, and it's really just waste. However, supply leakage into conditioned space, say we have an open ceiling and low pressure ductwork, we still might be delivering some of the energy or some of the outdoor air, but it's going to be less optimal. So essentially, we're losing efficiency, which is going to impact energy as well. And then finally, equipment leakage, do we care or not? Well, we do have to have considerations for the type of equipment we're specifying. So here in the bottom right, we can see a series fan powered box, which has this blower on the discharge of the product attached to the whole kind of integral casing here. Series fan powered box is negatively pressurized. Any leakage that might occur is actually leakage in from the plenum, which frankly, is going to have no impact on our system leakage whatsoever. It's just going to be entrained return air that's already closer to the condition we want it to be. It's not actually going to have a super negative impact because of that. Series fan powered boxes don't have any leakage specification for the casing. A single duct, though, is potentially very high impact. So we're mostly going to talk about single duct VAVs. I'll pause really quick. I'm going to check the chat, see if there's any questions. Don't see anything too critical there yet. I'll address some questions at the end. Are there any questions in the room as we're continuing here?
Oh, keep her going, Mark. Good stuff.
So when we think about terminal installation or terminal leakage specifically, looking at the leakage food chain, you know, this is, I guess, more affirmation of this being really low pressure class. The dividing line between medium pressure, which we really don't see in installs most of the time, and low pressure, when we look at, you know, ASHRAE and SMACNA, we're usually seeing somewhere between 1,500 and 2,500 feet per minute as the air velocity within ductwork that's going to define medium pressure to low pressure. Now, when we look at a terminal unit, terminal units are generally installed with at maximum 2,000 feet per minute through the terminal unit inlet. The reason for that is actually interesting. Primarily, it's because above 2,000 feet per minute, we're going to start to see generated noise. So air by itself, self-generating and creating more noise just from the air moving through ductwork. So we start with an acoustical rationale why we don't go above 2,000 feet per minute. The terminal is too close to occupants, too close to the zone. We don't want to make it loud. And the byproduct of that is the inlet is the smallest cross-sectional area of the terminal. The ductwork downstream is going to be larger. Therefore, we're firmly putting terminals always in low pressure duct systems. They're always plugging into low pressure duct systems in really every installation, vertical market, doesn't matter the application. Terminals are almost always low pressure duct systems. And so that kind of moves us to the SMACNA discussion and the ASHRAE discussion of if it's a low pressure system, what kind of duct leakage is acceptable? And, you know, Tom spoke to this in length, so I'll just give my 2 cents really quickly and start off with SMACNA, who SMACNA's recommendation, or what they kind of state, is if the engineer is not specifying a particular duct leakage class or a duct seal class, it should be a 2-inch pressure class for ductwork between supply fans and VAVs and a 1-inch pressure class for ductwork downstream. So that would mean seal class C, those transverse joints, essentially a slip and drive. We're going to seal a slip and drive. And that's going to mean the leakage class for that ductwork is, for rectangular ductwork, 24. Now, my argument would be that leakage class is too low. At that point, we're looking at, you know, quite a few CFM potentially leaking out of the ductwork, and I would argue it's insufficient, which is why I would really stress to consulting engineers, specifying engineers, to really exceed SMACNA's minimum requirements. And I think probably if you talk to most people at SMACNA, they would probably recommend the same thing. I think it's mostly CYA and coming up with light commercial best practices when an engineer might not even fully be involved in a project. Now, what does ASHRAE say? Well, ASHRAE says VAV boxes and downstream ductwork should be a 1-inch pressure class for if it's tested, but at a minimum a 1-inch pressure class with 2% maximum allowable leakage. So this is exceeding the requirements from SMACNA. This comes from the ASHRAE handbook. It comes from ASHRAE 90.1. And so what does that really tell us about terminal equipment leakage specifically? Well, that tells us terminal casing leakage should be 2% or less at 1-inch water gauge. And that is really what feeds into most manufacturers' specifications. So I have the price terminal specification on screen here on the left. And what we can see is casing leakage for the basic assembly should not exceed 1% of the max rated airflow at 1 inches water gauge. So when we're looking at that 2% recommendation from ASHRAE, we're saying 1% for the VAV box, 1% downstream. That is maybe not ideal, but that is how all manufacturers tend to do it. When we look towards a higher pressure, casing leakage for our casing should not exceed 2% of max rated airflow at 3 inches. So increasing the pressure threefold, only resulting in 1% extra leakage. This is where those specification recommendations or specification notes from manufacturers come from. If ASHRAE says, yeah.
Yeah, just real quick, I think you said it, but I'm just double checking. It's 2% of, like, if I have a 10-inch box, 1000 CFM max, 300 CFM min, it's 2% of the max. So 20
Correct.
CFM, okay.
Yeah, maximum rated airflow. So generally, a 10-inch box is a great example. A 10-inch box, 2,000 feet per minute, we're often seeing it selected around 800 CFM at the upper limit as far as kind of max cooling applications. That 800 CFM at 1 inch of pressure should be leaking 8 CFM. So 1% of 800, 16 CFM if we're looking at 3 inches. And that's kind of just the stock standard out of the box terminal. It's that maximum cooling rated airflow.
Got it. Thank you.
You bet. So the second question, this here is, how does duct leakage inform terminal equipment leakage? My next question would be, well, how does duct leakage potentially inform terminal equipment installation? So if SMACNA is indicating low pressure ductwork should be seal class C at a minimum, that would mean we definitely need to be sealing transverse joints. So slip and drive connections or the lap joint that we're going to see at the inlet of the terminal. Those need to be sealed at install. However, ASHRAE recommends 2% leakage for the low pressure ductwork system. And that's really closer to a seal class A or a seal class B. And we do see in California, for instance, class A being the requirement. And when we look at that, I'll go back to here, it's small, so I apologize for the small text, but seal class A is joints, seams, and wall penetrations. Most VAV boxes installed in California, even though we can kind of meet the spec already, they're often having contractors seal the wall penetration. So where the inlet meets the inlet panel, the round meets the flat, so wall penetrations. They are sealing transverse joints, so they're sealing slip and drives between a single duct and a water coil, or the water coil downstream. And they're sealing box seams at times too, which is probably overkill, but that's often what we see in installs in California. My main takeaway would be, if we need seal class C at a minimum, those transverse joints, those slip and drives, all those extra accessories should really get sealed in the field as well. The actual seams of the terminal, in my opinion, the industry should and can expect seam leakage to be managed by the terminal unit manufacturer, but we do not seal externally slip and drives. Unless it's required, we can do it. We often do for different projects. It's an option from price, but the stock single duct, which many of you would use regularly on projects, does not have slip and drive sealed. The expectation is those would be sealed in the field. So that's kind of my background on where we're at with leakage, how duct leakage impacts terminal unit leakage. But I want to talk a little bit more specifically on the leakage of a single duct, how it works, what options are available, and how that could impact your workflow as engineers, the workflow of installing contractors, and really the specifications that we see in market.
Mike, I got a question regarding the class A or B for the ceiling in California. Is that a code driven or is that just standard practice by the engineers?
That is code driven. So California code, it's called Title 24. And the code is kind of a combination of a few things. Higher requirements from ASHRAE following ASHRAE Guideline 36, which is viewed as the kind of pinnacle of energy efficient sequencing and operation of HVAC systems. And then also some other nuance that's local that has gotten added to code over time, but it is code enforced in California.
So it's only a matter of time before everybody here in the Midwest is gonna have to follow suit to some degree along those same, I hope.
Yeah, I would say
Don't hear much
very
about it.
likely. That tends to be the trend. We usually see things in California, start in California. They then usually get picked up next in Boston, New York, and the Pacific Northwest. I would say the typical install for Boston and the Pacific Northwest at this point is Seal Class A as well. New York is a race to the bottom type market very frequently. Cost is a huge issue in New York, so they tend to manage things on the engineering side before they actually get mandated on the contractor install side, because cost is such a component in New York that's always very interesting.
Thanks.
So on screen here, I have a couple different spec items from a few different manufacturers. The first is Naylor. So the big takeaway with Naylor, and when we compare it and look at it in comparison to price, it's really the same thing. And it's based off of that ASHRAE recommendation of 2% leakage for 1-inch pressure class, low pressure ductwork. So Naylor and Price manage it the same way, 1% at 1 inch of pressure, 2% at 3 inches of pressure, tested in accordance with ASHRAE standard 130. We do the exact same thing at Price. Interestingly, Metal Air only specifies damper leakage based off of seeing and reviewing their construction. I think they actually do it very similarly to us, but interestingly in their spec, there's nothing for the casing, which is maybe an oversight, I'm not sure, but is interesting, and I thought I'd point that out. Then we look towards Titus, and Titus manages it very differently. They manage it with a table of leakage values per inlet size. I will say, looking at Titus actual performance, or looking at the percentage and kind of doing some math to look at the table and compare it back to percentages, pretty much the same thing from Naylor and Price as well. Really no difference in construction or specification, just a different method of showing it. I think it's primarily, my guess would be, putting on my business development hat, them being a disruptor and trying to make it challenging for other manufacturers if they're specified. But really no major difference. When we actually look at the leakage performance, and I'll open this up by saying my intention here is to really just give you guys all the goods. It's not so much about negative selling or pointing out different constructions from different manufacturers. We actually got sample boxes from all of these manufacturers and tested them in our lab to ASHRAE standard 130 test conditions. And when we look at the damper leakage, really Metal Air, Titus, Price, negligibly different as far as the way they actually perform. We're looking at close to testing tolerance when we look at some of these percentages. I'll still, raise my hand and be happy to say Price is at the bottom of the curve. We like to see that as a manufacturer, but really negligible differences there. Naylor a little bit higher, starting to be maybe something measurable or something to consider when choosing equipment. Casing leakage, though, is much more important to actual leakage performance. The damper leakage, the damper is usually open. It's very infrequently closed all the way. It happens, but most commonly the damper is open and operating somewhere from 25% open to 100% open. Casing is what really matters. And when we look at casings, Titus, Metal Air, and Price, once again, perform very, very similarly. Naylor's a little bit more elevated, leaks a little bit more through their standard casing. Now, I also want to call attention, because I'm going to speak to this in a couple slides, but Price has re-engineered our single duct box specifically for lower leakage. And I just want to note, we did manage to shave our casing leakage even lower. I'll talk about how we did that, why we did that, and potentially what other options that's going to impact in industry moving forward that we'll start to see in the summer that are exciting. But I'll give a bit of a sneak peek at some of that. So that's our equipment leakage. That's the casing leakage. But does terminal unit specified leakage include accessories? The answer is no. And it's unfortunate, but it's true. The main reason why is there's so many iterations of product, you know, different rows of coil, different sizes of coil, different access door options, whether it's screws or different latches, top and bottom access doors, different sizes of access doors. Price terminals have silencers, as do nailer. Electric coils are another option that leak very differently, and I'll speak to that. But when we look at those transverse joints and when we look at access door seams, that is not included in specified language. And is that a problem? I would argue, yeah, it's a bit of a problem. But that is the way that product historically has been specified, the way that manufacturers build it. So I'm going to raise the kind of red flag to say it's something to consider. It's something that we're working on managing and offering a better method of doing this to the industry. And I'll speak a little bit to that too, but independent of manufacturer, you have to know an access door is not included in their specified language.
So do I have to have the contractor seal that? And if I have them seal it, does that nullify warranty that I have for your piece of equipment?
Not for sealing.
I mean, if they,
So
you got
generally,
4 joints, I mean, a panel and.
so transverse joints, 95% of the time are managed by the contractor in the field. Sealing those joints will have no impact, I'll say with 100% confidence, on price equipment warranty. I'll say with 90% confidence on any manufacturer. I don't think anyone's going to void warranty or have warranty issues with the sealing of transverse joints whatsoever. I'd be disappointed if another manufacturer did. I don't think it's likely. So normally those are getting sealed, because I'm going to just give myself a little laser pointer to make sure we're all looking at the same thing here.
Can I specify that you
realistically-
guys seal the access door? Like, can I specify leakage rate for that access door upstream and downstream of the coil that you guys provide me?
Absolutely you can, and I'll tell you what I think you should specify in one slide. The transverse joint downstream is getting sealed. So usually the transverse joint upstream is going to get sealed as well. Now, we seal our own wall penetration. So we put silicone caulk on that in the factory. I see some contractors still reseal that in the field just to reduce risk. I would say that's not necessary. I would also say it's unnecessary to seal the seams of the terminal, but some manufacturers have worse leakage performance. So it's maybe something to even consider. I think it's over the top and not required though. As far as the access door goes, I'm just going to change back to my mouse. So we did testing for our access door, and we're going to start to put this in our specification. It's something that's going to happen by summertime. I'll talk about why there's a little bit of lag there. But Price Industries quarter turn snap latch, or screw access doors perform quite well for leakage. 0.1 CFM at 3 inches of static pressure, 0.3 CFM at 6 inches of static pressure. This is using the ASHRAE standard 130 leakage test method. So essentially installing the terminal as you would in an actual install, taping off all the seams and taping off ductwork seams and transverse joint seams, and just specifically looking at leakage only through the seams of the access door. So very low leakage. I would probably recommend for specification language that we should have less than 1% leakage at 3 inches of static pressure for an access door specification. That would be my recommendation, because that would give you competitive options from multiple manufacturers, and it would cover you for leakage. Of course, at price, we could go more aggressive with that. This access door leakage is independent of casing size. But one thing I'll say with price that we've seen is the first, second, and fifth time this access door is opened and closed is not an issue. The 50th time the door is potentially opened and closed, you can start to see some leakage deterioration because of the gasket starting to wear and break down, and potentially a contractor not putting it in fully square, or as they take it out and put it back in, starting to deteriorate that gasket. And that's actually the reason why price will be moving forward with adding some language to spec in the springtime, summertime, because we're actually fundamentally redesigning our access door for more gasket resiliency, a different gasket type, and actually a larger access door as well. We're going to be moving to a 9x9 access door that is going to be constructed a little differently. It's going to have rounded edges because most of the leakage occurs through corners, and it's going to have a pre-manufactured OEM gasket that's going to be more resilient over multiple cycles of use. So does our leakage of our access door perform great right now? Yes. Am I concerned about the 50th time you open and close it and some deterioration? Also yes, which is why we're managing that and coming out with a new option. Other access doors in industry are also very interesting. I know Tom showed these FlexMaster doors. The FlexMaster doors are fantastic. We sometimes get specifications and see specifications for FlexMaster doors, and we will actually install them at our factory ourselves. Now, one thing that I'll note, which we manage at the factory and we see regularly, and you'll actually see on the contractor end, it's not so much how the door performs, it's sometimes how is the door installed. So different FlexMaster doors have different leakage rates. We can see when we compare square access door, up to 14 CFM at 4 inches of pressure. Round, because of having no corners, the gasket seals a lot better. We see only 2 CFM at 10 inches of operating pressure. That is the door by itself. If the door is misinstalled, that leakage rate can increase. So round doors are a benefit, but also install is a requirement. Proper install is a requirement. And that's why testing is sometimes a benefit in the field as well. If you install a great door, but don't install it correctly, it can still leak. Now, so round doors are better. That's one takeaway. The other thing that's an interesting takeaway is there's very different test methods here. So ASHRAE standard 162 for FlexMaster doors, that is a leakage test that only looks at the door specifically by itself. Essentially, the actual mate of the door to the ductwork is very built up to assure that only we're looking at the install of the door. ASHRAE standard 130, which is our method, actually includes installation because we have leakage out of the seam of the door to the mate to the casing. So ASHRAE 130, a little bit different. The bottom left, we have Naylor's door. Naylor's door is actually quite a good door. We're going to be building something, I'd say somewhat similar, maybe a little bit more elevated too. They use a British standard DW142. I'll be honest, I don't even know what that is. And I don't really know why they're using a British standard as a Canadian-American manufacturer. And I don't know the implications that would have the actual performance of the door when installed. And also that is directly out of their spec there, just for what it's worth. Any questions there on access doors?
Mark, I think there's one in the chat from Heidi.
Okay, I'll check that out really quickly. Heidi, any preference for latches versus screws on access doors? If they have the same gasket, seems same for leakage. My thought is screws are less preferable because it allows the door to not be replaced during troubleshooting. I would also argue, it's a little bit of a cost add, and that's why we often see screws used instead of latches or quarter turn sash latches. I would say specify a latched door instead of a screw door. If you specify that, then you're going to get an equivalent option from all manufacturers. And I think it is preferable for reinstallation of the door after servicing or testing and balancing or cleaning of a coil or whatever you might be doing maintenance wise. You're going to have a more repeatable install with a latch rather than a screw. So my recommendation would certainly be to go for a latch instead. Thank you for the question, Heidi. So equipment leakage and how it works. Another thing I want to note here is our reheat options. Oh, sorry. I had one slide there. When we look at reheat options, different reheat options also operate quite differently. So a transverse seam for a hot water reheat coil generally is going to get your leakage performance for the terminal within spec and is very easy and manageable to do in the field. My note to any engineers who utilize electric coils is be aware, because electric coils and duct mounted heaters of any kind, whether it's on a single duct or just in the ductwork, they need to slide out for servicing. And that means leakage performance and availability to really meet your spec might vary. At Price, what we do to manage this is we actually gasket. We can gasket around the seam as an option. Generally, you know, that isn't something that we see specified or required frequently. And by the nature of the business, you know, trying to lean out pricing and be as competitive as possible, that's not something we automatically do on every box because it's not something we see for any other duct mounted heaters or manufacturers. It can be managed in that method. The other reality is electric coils do simply just leak more and worse than other reheat options, which is a consideration and one I'll call out. I know I'm kind of raising many red flags as engineers, maybe leaving, or as a manufacturer, leaving engineers with questions rather than some answers. But I do think long-term leakage is something that will have to be managed kind of by all elements through the HVAC industry. So we do have a certified low leakage electric coil, which is also something you consider using. And I want to talk a little bit about certified low leakage here on the next slide, but I'll maybe just pause to see if there's any questions on electric coil leakage quickly.
Looks like Pat has his hand up.
What do you need, Pat?
What's up, Pat?
Question? Oh, there's something in the Q&A.
He said he's good. So we'll continue here. Okay, so I want to talk about certified low leakage as well, and talk a little bit about why you might choose to specify it and how it works. So the first thing I want to note with this leakage test that we're seeing on the right-hand side of the screen, the factory leakage test and the field leakage test are essentially the exact same thing. We're sealing the equipment. We are pressurizing the equipment up to 6 inches, and we're essentially measuring through this tube additional CFM required to hold and keep that pressure. And that's how we figure out the leakage of the equipment. So the inlet is sealed by essentially a large cap. This is like the low leakage cap that you would put on pressure testing ductwork in the field. It has an inflatable gasket, so it makes a very, very strong low leakage seam. And that's what allows for the pressurization of the casing. Other thing is this very gross yellow putty bed. And so that is like a 4-inch deep bed of putty that we actually push the seam and the connection of the terminal into to create a really good mate and seal on the discharge side of the equipment. We then pressurize the casing. We measure the internal pressure of the casing through the static pressure side of our cross-flow sensor. And at the factory, we test to 6 inches water gauge. So essentially every single box would be pulled off the end of the line, taken to this rig. A test occurs. The test usually takes maybe 10 minutes. And the big issue is if there is a failure, it's going to require rework and then retest until construction is conforming. And that kind of speaks to the expense of certified low leakage construction, because it's quite a cumbersome process when you look at a lean manufacturing production facility that's trying to work on one piece flow and getting things from raw material to finished product as quickly as possible. However, it is a service that we can provide. So to speak to leakage construction options in a little bit more detail, historical construction that most manufacturers use is a hemlock construction, very similar to a Pittsburgh lock, but it's not folded over twice. This hemlock construction does have some additional mechanical mating to really squeeze kind of that blue piece of sheet metal into the green piece of sheet metal. And, you know, this is a very repeatable performance. The new construction is one that we've kind of improved upon. It uses gasket and screws. And so that's our new construction. Big reason why we're using this new construction is because long-term, the goal for us is actually a different single duct construction that's going to perform better. We're going to be releasing a new fully reconfigured single duct this spring. That's going to be a higher pressure class because of the damper position. And so that's something to make note of. And that's why we're transitioning to this casing construction instead, which performs better. The last option is certified low leakage. And that's a really important one, which we were kind of discussing there. So certified low leakage, every manufacturer does it a different way. The goal is just to not make the box leak at all. So Metal Air is using hard cast tape, purchase access doors, and dual wall coils. Nailer has a reinforced damper opening, spot welded casing, which is very considerable as far as cost of construction, and mastic sealed transverse joints. So they actually seal that themselves. We do something similar. If we go back to this video, you can see mastic sealing. We use screws and gasket. Fortunately, our construction's a little bit more affordable there. My last takeaway slide here is the standard construction is most affordable for upfront cost. The casing and the damper leakage would be as specified. Accessories are not accounted for, but you can specify access door leakage. Low leakage construction is another option, which is actually only from price. So this gasket seams for further casing leakage improvements. We have a double gasketed damper. We have larger, lower leakage access doors, and we hard cast tape seams and transverse joints whenever it's necessary. However, this doesn't test in the factory. It's the construction without the testing. So it comes at a lower cost. This is my recommendation for what I think should be specified. If I was a design engineer, this is what I would be specifying: a low leakage construction without the factory certification. Finally, the factory certification is gold plated maximum option of the above plus factory test and certification.
Who's requiring the certified? Is that like is lead requiring?
Owner. The owner wants.
Or just the owner? Okay.
It's coming from the owner primarily. So we see that in Texas. We see that sometimes in California. I think most manufacturers historically haven't had an option in between. So if a really harsh leakage spec comes up, harsh, I would say required leakage spec comes up, we see manufacturers defaulting all the way to the high cost option. That's why we've inserted this kind of medium option that's the same construction, just no certification. And that's why I recommend it as well. So that's my spiel on leakage. I hope I gave some good insight on why it matters, what you need to consider, and options that exist. I think I went a little bit over time here. I appreciate some of the questions, but I'll hand it back to Tom at this point.
Hey, thanks, Mark. Great job. Appreciate it.
Bet.
In the interest of time, Mark and I just ran a little bit long, so I'm just going to go right through our studio audience. Since you use the washroom, go right ahead. But I'm going to hop right into the outdoor ducting. It's the lavalier sound thing. Turn that. So if there's any issues with sound in our remote audience, raise a hand, but hopefully it's good. So in our first section, we talked a little bit about Koolduct, did a little bit about high pressure duct work. What I'm going to do in this section is Great. Just talk about how we go from indoor ductwork to outdoor ductwork. If we're gonna make it with Koolduct. Then I'm also gonna talk about just metal ductwork in general. Airflow is the rep for Thermaduct. That business partner that I had, it's called Special Operations Ductwork. He was a special ops guy for 16 years. He used to jump out of airplanes and establish airplane so that's a separate business that is manufactured here on our premise. So let's, oh, I have the, hey, got the controller here. I'm waiting for you guys to advance the slides that I can do it. I think. Remote control. Okay. So we're just gonna, here's what we're gonna be talking about quickly. Just, you know, well, you guys can read what we've got here. Thanks. All right, this is a consulting engineer sent me this picture. This is a great picture. Why is it a great picture? It shows the ducts in various stages of being installed outdoors. So when I think of outdoor ductwork, I think of the ductwork's already there. It's wrapped, it's installed, it's on structure, it's insulated, it's got the cladding around it. Okay, so what we see here is, here's how the ductwork starts, just high pressure ductwork, right? And then this insulator is going to come in and lay his insulation over the top. Whatever that insulation is specified as is up to the consulting engineer. And then it's gonna get clad. In this particular case, it's clad with something that I wouldn't normally see. It's clad with some roofing material. In other cases, it's clad with some, this is not that unusual, and we hear about roofing, just we're gonna roof it in. Or it could be clad with just an aluminum embossed skin, or it can be clad with venture clad, which is a peel and stick kind of a thing, and you kind of squeegee it together. So what do we see? Looks fine to me, right? It's just ductwork on a roof. So we've got this 4-bolt, and I'm gonna go through these in detail, but we've got the 4-bolt construction that we need to deal with. We have some insulation challenges. We've got a lot of caulking. We've got some surface temperature stuff. Let's go through those one at a time. So we need to kind of, if we're gonna wrap this ductwork with cladding, and then we've got that flange, we kind of need to chop off our insulation or insulation where the 4-bolt flanges are. Now, is that the biggest deal in the world? Probably not. It's just a small detail, but it's a detail. Okay. A bigger issue is, you know, we saw a couple slides ago, that ductwork starts off as a piece of metal and then it sits on the support. So how do you insulate that? Well, you just don't. The metal sits on the support, and then you kind of cobble some wrapping of insulation under the support. That doesn't make any sense because you compressed your insulation. And are you gonna wrap around this? So I think, who knows what goes on in the field? It's not really probably a detail that most engineers can really sort out. You've got support, you've got the metal ductwork on the top, and then you kind of insulate and cobble around and do the best thing that you can. Okay. When we get around the corners and it's a radius elbow, you have to chop the insulation to a certain extent to get it to follow. If it's probably less so if it's, you know, like mineral wool. Then again, it's mineral wool, so if it gets wet, you've lost all your insulation. So there's an interesting challenge too. This is a more rigid insulation, which I think is good, but there's upsides and downsides too. Now you can see this particular, there's a lot of caulk. Maybe that's good. Maybe that's good. Maybe it's not good. Did the longitudinal seam, now we talked about high pressure ductwork, so you gotta see, there's no wall penetrations in high pressure ductwork on a roof. Generally, there may be T's and taps, or not taps, but T's, right? You may have a branch going into different openings through a roof penetration. But did this horizontal longitudinal seam get sealed? Hopefully. You're never gonna see it. Never gonna know, right? when we see the ventriclad bubbling out, we might have an idea of whether it got sealed or not. And then this roofing material, will pick up heat. So we're gonna have a delta T between the surface temperature of a black surface or a gray surface. And then some of that heat is gonna go into the ductwork as we're doing air conditioning, assuming it's air conditioning ductwork. Okay, so this is a very detailed spec that I pulled off of one of our engineers, and they're talking about jacket. So that's, in this particular case, Roger, might be yours.
Doesn't look familiar, it could be from my firm.
Yeah, it could be from your firm.
Yeah.
So we've got supply ducts exterior, so they're talking about a jacket type D3 and insulation type RR, which I assume is rigid. And then the thickness of the insulation, it should be also an R value. So here's what it was, R rigid mineral fiber board. So they're taking these rigid boards, and you saw that they got notched in order to make it around the bend, and there's often a lot of bends. If it's all square elbows, maybe this isn't that big of a deal, right? And it should be, gives us some types. Don't see that it tells us the R value, but I'm sure if we went back or dug into what the R value, it would be driven by like our ASHRAE class. If we're R12, if we're further south, the R value is gonna be 8. Go further north, I mean, I think this 12 is high as I've seen, unless it's a specialty project and it can be R20 or something. Okay, then here's the jacket, self-adhering, multiple laminated waterproofing material. So this is called peel and seal. So you have a long sheet and you pull it out and you wrap it around, not the metal, wrap it around the insulation that's kind of floating on the top. And then you take a squeegee and you squeegee it. So it's sort of stuck to the insulation, but not necessarily. You glue the insulation, the hard insulation to the metal, and then you put this on top of the rigid board. But if you have, wrapped insulation, it's a little less sturdy. So this is actually a pretty good spec. And they're, white embossed, so it sort of has the chance of looking kind of nice. So there's something there. One question I ask is I often see like ductwork that is sort of one on top of the other. And when the ductwork is one on top of the other, I can imagine that poor insulator's got to get the insulation between, then he's got to get his jacket through. So you got to kind of jack up between the two sections to leave enough room for the insulator to do his job. And I can imagine a lot of insulators go, look at what they left me. What am I supposed to do with this? But anyways, I don't know that this picture actually represents that, but anyways. Okay, yeah, some installation photos. Back to this picture, this here is telling us, even though that's high pressure ductwork, and every contractor knows how to make high pressure ductwork really well, and they know how to seal it, this is a brand new install, it is clearly bubbling out. So what's bubbling out? It's bubbling between the insulation, this is the peel and seal stuff. So it's pushing the insulation away, right? And it's got to get through that peel and seal somehow. Now it's holding it, but is it in the ductwork anymore? It's not. So we've leaked some. How much did it leak? I don't know. No idea. If someone did a pressure test, they would have needed to have done it before the insulation is attached and the ventriclad is on the top. So I don't know. And odds are this owner doesn't know, and odds are nobody tested it. Okay. More pictures of bubbling. Very common to see bubbling with ventriclad. Okay. I don't know what else to say about it. So I'm going to talk a lot about phenolic duct, in just that when we make duct out of phenolic, SMACNA, Sheet Metal Contractors Association, they have a whole standard book. When we build ductwork, we follow this book. There is another book for metal duct that looks exactly the same except metal duct instead of phenolic duct. So we have a real book. This book gets updated and we build very, as close as we can with everything that we do to follow this book, so we maintain the warranty. Because when we build ductwork, it's got a 10-year warranty. We've had plenty of challenges over the years replacing other ductwork that other contractors have made out of phenolic over time. So this manufacturer that we work with upholds this 10-year warranty for real. Okay, so this is the indoor product. So we saw Koolduct examples in the first section. They also make round, they also make oval, you know, it's cool stuff. When we use R8 fiberglass versus R12 phenolic, we see that there is a space advantage. Now, R8 fiberglass, typical indoor insulation, we can't like squeeze that and keep R9. It's gotta be loose, right? But sometimes we're in the tight spaces and we gotta band it, so this insulation loses some of its value when it collapses. R12, you can stand on it, it doesn't collapse. So it is rigid, it is rigid. You can see some of the benefit of having the ductwork and the insulation be the same. If you're in a tight space, you can put the ductwork adjacent. You can also build 2 or 3 ducts in the same box with a septum panel in between. So you can separate different zones, or you can have supply running one way and return running the other way, or exhaust or something like that. In a case like this where you're trying to squeeze between trusses, you don't need to leave room for insulation. You can just lay it right on top of a metal or raise it right up to a deck. So you can get away with some stuff that you can't get away with metal, which is kind of cool. Most contractors want to put in metal, fine. This is a great fix for a really tight space. It's super light. Look at that kid. He would have fallen over and it would hit him in the head. But it's somewhere between 1/8 and 1/4 of the weight of metal. So there are some advantages. And of course, it's insulated. The insulation is the duct. We already talked about leakage rates. The leakage class for all the outdoor duct product that's vinyl clad is 1. So super tight. We talked about this. I actually made my chart wrong. It's 1/3 of this number. So leakage class or leakage in 100 square feet is 1 point something, very low per 100 square feet. This is fun, you know, when you when you're welding ductwork, or when you're welding galvanized, it gives off gas. You can hold a blowtorch to this stuff and then put your hand on it afterwards. It's just, I don't make phenolic. It's just amazing what it does. So it's UL 181, means you can't burn it, it won't turn into smoke, flame, smoke, all that rating stuff is covered. This product has all these cool 181, you know, you can't grow mold on it, it's hard to put a hole in it. You know, it's not metal, but boy, it sure behaves like metal and then has some benefits beyond it. I'm going, this is a quick little, can you hit play? I don't know if I can. I'm just gonna take that nut, take a blowtorch to it. I mean, that's amazing. Yeah. Yeah, I'm not recommending you set all your ductwork on fire. However, if you decide to, you're gonna have a hard time burning this one. That's galvanized and insulation. That's what happens in a fire. That's bad. Ooh, that's really bad. All right. Anyways, showed you videos on high pressure ductwork being built, so we don't need to cover this again. All right, so we have this indoor ductwork that we made. How are we gonna make it suitable for outdoor ductwork? Now you could conceivably take our high pressure ductwork and venture clad it and say that complies with the metal spec. We don't want to do that. That doesn't get a 10-year warranty. You could do that. And in some territories, they've built that. And it would be cheaper than building the vinyl cladded stuff, but we're gonna not go there. We're gonna move ahead. So on the left, this is the king span board. When we build Koolduct, that comes on a big skid. We cut it on that machine that you saw earlier. This is the impregnated vinyl board. So there's vinyl on one side, and then if you flipped it over, it would look like this on the other. So all it is, got one sheet of vinyl on it. So then we have this air knife. So we're shooting hot air through the table where the break is, and we're just bending it over. Now, when in metal ductwork and in Thermaduct, we're gonna have stiffeners, so we have supports. So when you see those, it's gonna go over here. That doesn't help.
You see the little circles.
Yeah, go, yeah, thank you. Yeah, right there, so there's a little conduit that gets put in. So as duct gets bigger, we put in conduits, which are just basically stiffeners. Sheet metal ductwork has stiffeners too. And then those covers go over the top. And then as we're building that ductwork, thanks, just pause it there. So we talked about when you build ductwork and then you end up with, you're bringing the two sections together. We put this corner on, and then they're gonna caulk the seams with a certain caulk that, you know, is listed with this system to keep the 10-year warranty. It's a mastic. So it's quite a production to make it happen, but that's what's required in order to do it. I showed you this before. There's a lot of material. As Thermaduct, we've got the vinyl on the outside. Sometimes there's a corner when the pieces come together. Here's our Koolduct with our traditional duct with our ceiling.
So where does the flange get put on the?
The flange goes, where does it go on?
Like, does it go in the inner? Yeah, for the.
I think I covered that. Okay, I'm gonna just pause this video, please, Sienna. So you remember how you saw the 4-bolt flange and it just had one, you know, there's a flat part and then there's the part that goes into the duct. And it just goes on the outside.
Okay, it is just.
This has a groove.
Yeah.
So you caulk in the groove, you turn it around and you put it
Okay.
on the end,
Yeah.
right? So it's receiving on both sides of the insulation. So it's a different, which sucks, truthfully. That flange, we gotta get it from the manufacturer. It's a really expensive flange.
Yeah, but.
And it's gotta be the right size for the insulation. So if you've got an R8, sometimes we build stuff for Seattle.
Yeah.
R8 is a different flange than the R12, which is different than the R20, so we have to get specialty
Right.
flanges. But then it goes on the outside. So this has got the flange on it, and all the contractors doing the same old butyl tape, just like always for a floor bolt connection on the roof. Let's go ahead. So prep, there's the gasket, we just showed that. Next one, I think, wait, if we go back here, does this show how long is that video?
23 seconds.
Okay, great, yeah. Can you pause it right there? So this is, yeah, that's the 4 bolts, so you're putting the cleat on, right? And if we advance it a little bit further, that's the gasket to protect the flange, right? Because we don't want the flange to swell, we don't need water in there.
Yeah.
So that is protecting the 4-bolt flange. And then if you play a little bit further, now we're putting another piece of vinyl. This is kind of a pain.
Is that insulated already?
So that black stuff, I'm trying to remember what the black stuff is called. It might be in the next couple slides what it's called. It's just it's not insulation tape, it's just like a spongy gasket.
Yeah.
Is it like fiber-free foam and stuff?
Yeah.
Kind of like that, exactly.
But is that white piece that he's putting on now, the cladding, is that insulated?
That is not, that is just a cover.
The foam is the insulation. so.
Yeah.
So, but the foam isn't gonna be the same R value as the board.
That's true, that's true.
That's
But
where I was going.
when the two sections come together, they're fully insulated and the flange pops out.
Okay.
And then now he's just got a caulk and it's basically glue and caulk around that cover. So this is probably the worst part of the job is, so we have a little sticky tape that goes on both sides. You put it over that gasketing and then you caulk it to hold it because that little sticky tape isn't gonna hold it forever. So then it gets sealed up and then they take a rag and push that insulation all the way into the corner. So It should be faster in the field than conventional sheet metal type stuff, and of course, you're done. Like, there's no insulator that's gonna come out, there's no clatter that's gonna come out, job done. Prep. Connections, then there's what an insulated tape is what Thermaduct's calling it. And then the cover. Okay. This is, I think I built this a little while ago. I think what I was doing is just showing, insulation's not that cheap. It is more expensive to buy Thermaduct than it is to put in metal and then get the insulator to come out, but if you specify like mineral wool and peel and seal, it's gonna be cheaper. If your insulation is more rigid, like rigid board and a higher grade, then the gap narrows between the two. And of course, it doesn't compress and all that other good stuff that we talked about. Our 1,000 micron compared to the specification that we saw, it's over two times as thick, right? It's, I didn't convert this all that well, like, what is 0.016 thick aluminum? Is that thick or is it not thick? I had no idea. Is 1,000 microns thick or is it not thick? I didn't know, so I just did a little math and it's, the vinyl is thicker. Yay! Okay. Let's see. This is just more of what we talked about before about building ductwork, steel class A, all that kind of stuff. Now I want you to take a look at this. This is a job that I think this is in Indiana. So we are in mid-construction on a duct replacement. So you can see we've got the insulating tape. I just want you to imagine the job that this contractor originally, this ductwork failed. They did an amazing job. Like, think of how hard the insulator worked to clad this ductwork. So he covered every 4-bolt flange with a cover. It's insulated underneath. You had to kind of feather the bend here. You can see though that they had to put screws through it to get it to hold. And then those screws are all rusting and failing. This is whenever they put this in, that's not to be trifled with. It's an amazing job what that insulator did. And also, it failed. Like, that stinks. It's probably better than what it would have been as peel and seal, but then again, maybe not. I don't know what would have been better, but that's a pretty tricky job. And it's a real shame that they had to put this offset in, because had they lined up the ductwork and the pen, like that, again, like, look at how much work that is. Anyways, that's what it looked like when they had to rip it all out, which is kind of a giant shame. And then that's what it looked like when they redid it. I know, it's beautiful, isn't it? It just makes me happy to see it. Anyway, so we're going back. We're gonna just touch on, I really want to show you just one slide. We talked about this. This is great, right? Now I want a couple of things to think about. You bring that metal ductwork out there, you set it on the structure. Is the insulator ready to go the moment that they get out there? No, that ductwork is gonna be sitting there for a little while. So odds are, even if they've taped, they put the blue sticky tape on the outside, there's gonna be some condensation in that duct right when they start it up, assuming that it's not ideal weather conditions, right? So is anybody gonna go in and try it? I don't know. But this, you tape it, we're already insulated. We're most of the way there once it's on the site. And of course, we don't need to wrap it. We don't need to cobble around the structure. If we want to have duct sections right next to each other, we can lay them. You wouldn't lay them right on top of each other, but you can put them as close as you can physically fit them.
What's that we go across the seam there, the transverse? What is that, stick out 2 inches? So like 4 inches?
You're talking about,
Yep.
very good, the transverse joint. That is like, yeah, that's like 2 inches.
So as long as you have 4 inches in between, when you start packing everything together to account for.
Oh, right, yep. Now, if you wanted to put, let's say that this was supply.
Yep.
And this was return, we could build that in one section with
And just have a single panel.
and have an R12 panel in between. So if you wanted to get really cute, That would be better than having it exposed to the outside.
That is really cute.
Yeah,
Well, you have 2 less sites.
absolutely. And then you're wrapping the whole thing around in vinyl once.
Mhm.
So that's something that can be done. Yeah, this is some, like, okay, maybe we're better, like, this is small potato stuff, like, maybe we're a little bit better in a round corner than that rigid installation was. I don't really think that's all that exciting, like, this is a terrible fitting, like that, we don't solve system effect problems with this insulated ductwork. But it does look good. Flange, yeah, that's fine. We've seen all this. This is the last thing, that white finish keeps the surface temperature of the ductwork down in summertime. Yeah, maybe there's some benefit to having a darker finish in the winter and you're picking up a little bit of solar gain. But in the summertime, and that even the silver stuff picks up a lot of temperature. So what color is this? The Thermaduct. This is just a test, a light test, right? And you can raise the temperature of the Thermaduct up to about 125. This is the vinyl cladded stuff, so silver picks up another 8 degrees. Metal duct, if it's internally insulated, goes up to 150 degrees. And then there's some ductwork on Abbott, it's all dark brown.
Hey now, hey.
Hey,
now.
look at that,
Hey.
look at that. It's pretty hot. And I just mentioned that exposed ductwork. I'm just trying to wrap up because we're on time here and we're just past 12. So it's just, again, saying that you're nearly finished when this stuff shows up on site. And yeah, there's 3D drawings and all that great stuff. Just a quick mention of a couple other products. We periodically run into issues where people don't want white or brown or whatever colors we have. We can do this Kynar wrapped ductwork if you have a specific color. I don't like white, but whatever. They are now making the Koolduct in round. When it's in round, it's leakage class 1. And it's also available in oval. So again, your tight spaces, again, contractors are gonna want to put in their own stuff. I don't blame them. If I had a coil line, I'd want to keep my coil line running. If I had a spiral machine, I'd want to keep my spiral machine running. However, if you're in a tight space or you want a tighter spec or whatever it turns out to be, whatever the owner wants, this is available. This is the outdoor ductwork in round. Yeah, this is a good picture of the oval. And yeah, more outdoor round.
I mean, I guess as a consulting engineer, if that's what the owner wanted, I should say, if that's what I want to ensure that the owner is provided, then the leakage testing is what needs to be addressed. Because at some point, the cost is gonna be greater for the contractor to install their own spiral system versus the Thermaduct.
No, we're almost always more expensive unless it's a higher R value, so R20 systems, we do really well at. If the specification for the insulation is higher grade and the wrap is higher grade, yeah, we can be, it's a premium.
What about the Koolduct that's inside that? I mean, if I call for class A and the leakage.
We're still gonna be a little bit more expensive.
Yeah.
And it isn't always that it's like exactly that it's more expensive, it's how the project gets priced up.
Mhm.
So if you go, hey, this insulator, I want a credit for this part of the job, they give you 25 cents or 50 cents on the dollar.
Well, what I see at times is my exclusion is I'm not doing pressure testing. I'm not doing the leakage testing,
Right,
right? So like, I don't have it, so I can give you what I wanna give you because I've excluded it.
there's a trade-off.
Yeah, right.
There's a trade-off. So it's, it's beauties in the, and again, so what is the purpose of all this? Purpose of all is to say systems leak, right? Like the white finish, like it's great. But at the end of the day, what is the point of all this? We really want systems, well, if you choose that your systems leak less, this is an appropriate option. There are lots of things that you can do in your duct systems to prevent them from leaking. If it's really $16 or $12 a CFM, then this is cheap. I mean, you think about coming back into a building and redoing the ductwork, you can't get a payback on, you never can get a payback on that. So building it right the first time probably is a pretty great investment. I wanna redo some of our system here and I'm like, oh my God. You know, I can take down ceiling tiles, no big deal. But taking out the ductwork and putting new ductwork in because we have a plenum return, oh my God, it's surgery. So that ductwork, it really ought to stay there forever and, you know, over time, it's heating and cooling, it's gonna expand and contract and expand and contract, and how good is our ceiling job? Well, day one, if you don't pass the test, how bad is it gonna be in 5 years? It's gonna be pretty bad. So, at any rate, I think that's my last slide. If there's any questions, fire them off in the Q&A. I don't know that there are any.
There's one from Heidi, she asked does phenolic have asbestos in it?
Phenolic does not have asbestos in it. It is, it's a product that's made by Kingspan. A lot of it is used for building insulation. But it's, as you saw in the video, it's kind of indestructible and meets you, basically what does it need to do? It needs to meet UL 181 to be a ductwork product. And it does. So no asbestos, and no, it's not fiberboard or anything like that. Okay. Well, if there are no other questions, thank you guys for learning about duct leakage and all the little pieces and parts, and hopefully you guys can, if you ever want help managing your specification or getting some ideas on how to do better enforcement, just send me an email and I'd be happy to help you out. Next class is on electricity for dummies. I know as a person who's in the HVAC trade for 28 years, I'm not that good at electrical, so we've got someone to kind of bring us along. If you're good at electrical, see you at the third class. All right, thanks, everybody.
Thank you.